Hi everyone, I'm Kian Leung. Today I will talk about the research paper ARSeek, Identify API Resource Using Code and Discussion on Stack Overflow. First, I would like to introduce the initial problem statement. In order to gain a deeper understanding of APIs and their user information, developers need to inspect many web pages manually, and Stack Overflow is a common place for the developers to discover APIs. Stack Overflow thread containing the fully qualified method name may help the developer learn something about the API. Therefore, our initial problem statement is for each API method in a set of given API methods, identifies the overflow threads refers to it. We have an example here. The developers learn about the API org.mockito.mockito.when by inspecting the example from Stack Overflow forum. On Stack Overflow, there's a thread which ID is A, contain the fully qualified method name that the developer looks for. Another thread B contain only the symbol name when this takes time of the developer to read the thread carefully to ensure that the ambitious simple method name refer to the API method he is looking for. If the Stack Overflow thread is falsely considered as referring to the API method, the developer will waste his time on reading the irrelevant examples. For tools collecting Stack Overflow thread for the specific APIs, getting wrong content may lead to a bad consequence to the program use the data collected from it. To correctly determine if a discussion refers to a specific API method, we develop ARSeek, a context-specific algorithm to capture the semantic and syntactic information of the paragraphs and code snippet in the discussion. Our goal is, given an API method, we try to identify whether a discussion's Stack Overflow thread refers to a given API method. ARSeek has two components. The first one is API relevant classifier, which captures the semantic relevance between the paragraphs and code snippet in the thread and the API method comments and implementation code. The second component is Datis Plus, which captures the syntactic relevance between the fully qualified API method name and the content of the thread. Now we first talk about Datis Plus. Datis Plus is an extension of Datis work, uh, and it captures the types of given API available in four scopes of a Stack Overflow thread. The first scope mentioned scope is that Datis Plus finds if the API mentioned in the thread come along with any class name that match the class name of the given API. Text scope is on the informal textual content of the thread. Code scope are the code snippet of the thread, um, as the code common in the code snippet can be both text and code. Datis Plus consider it as a special case and calls it extended code scope. From the for scope, Datis Plus outputs the syntactic relevance score between a thread and a given API following an algorithm mentioned in our paper. Next, we talk about the API relevant classifier. This classifier receives API relevant embeddings at inputs and outputs, the score indicating how semantically relevant between a Stack Overflow thread and a given API method. The diagram on the left-hand side shows how API relevant embeddings are created. Firstly, each thread in the potential thread needs to be converted into an embedding. We define a thread as the question post and its answer post. A thread may contain n paragraph and n code snippets. Each paragraph is paired with each code snippet to create a pair of thread content. Um, Therefore, a Stack Overflow thread would have m multiply n thread contain pair. Codebird is used to extract the semantic meaning of each thread contain pair and produce m multiply n thread embedding. Secondly, API common and implementation codes also need to be converted into the method embedding by the corporate encoder. Finally, each thread embedding vector and the method embedding vector are then concatenated into a vector. We call this concatenated vector, the API relevant embedding. In total, there are m multiplied n API relevant embedding vector would be created. After having the API relevant embeddings, we use them as inputs for the API relevant classifier. In the training mode, if the thread refers to the API method, the API relevant embeddings have positive label. Otherwise, if the thread does not refer to the API method, the API relevant embeddings have negative label. In deployment mode, the classifier produces average probability score indicating the likelihood that the thread refers to the given API method. Now we compute the choice relevant score C following this formula. That is plus an API relevant classifier output the score A and B respectively. The weighting factor is decides the contributions of Datis plus score and the API relevant classifier in the choice relevant score C. We define true positive is the case where a thread is deemed to be relevant by the approach is indeed relevant. False positive is the case where a thread that is deemed to be relevant by the approach is actually irrelevant. False negative is the case where a thread that is deemed to be irrelevant by the approach is relevant. The matrix precision recall and F1 score are calculated using the three definitions. Table 3 shows the performance of ARSeek compared to the baseline datas. On average, ARSeek achieved an F1 score of 0.87, which beats the baseline datas by 14%. And thanks for your listening.